By the way, you mentioned the Utah array, and I just saw a picture of that, and that thing looks terrifying
Yeah, bed of
because it's
nails.
it's because it's rigid, and then if you look at the threads, they're flexible. What can you say that's interesting to you about the flexible, that kind of approach of the flexible threads to deliver the electrodes next to the neurons?
Yeah, I mean the goal there comes from experience. I mean, we stand on the shoulders of people that made Utah arrays and used Utah arrays for decades before we ever even came along. Um, Neuralink arose partly, this approach to technology arose out of a need recognized after Utah arrays would fail routinely because the rigid electrodes, those spikes that are literally hammered using an air hammer into the brain, uh, those spikes generate a bad immune response that encapsulates the electrode spikes in scar tissue, essentially. And so one of the projects that was being worked on in the Anderson lab at Caltech when I got there was to see if you could use chemotherapy to prevent the formation of scar. It's like, things are pretty bad when you're jamming a bed of nails into the brain and then treating that with chemotherapy to try to prevent scar tissue. It's like, maybe we've gotten off track here, guys. Maybe there's a fundamental redesign necessary. And so Neuralink's approach of using highly flexible, tiny electrodes avoids a lot of the bleeding, avoids a lot of the immune response that ends up happening when rigid electrodes are pounded into the brain. And so what we see is our electrode longevity and functionality and the health of the brain tissue immediately surrounding the electrode is excellent. I mean, it goes on for years now in our animal models.
What do most people not understand about the biology of the brain? We'll mention the vasculature. That's really interesting.
I think the most interesting, maybe underappreciated fact is that it really does control almost everything. I mean, I don't know, for an out of the blue example, imagine you want a lever on fertility. You want to be able to turn fertility on and off. I mean, there are legitimate targets in the brain itself to modulate fertility. Say, blood pressure. You want to modulate blood pressure. There are legitimate targets in the brain for doing that. Things that aren't immediately obvious as brain problems are potentially solvable in the brain. And so I think it's an underexplored area for primary treatments of all the things that bother people.
That's a really fascinating way to look at it. Like, there's a lot of conditions we might think have nothing to do with the brain, but they might just be symptoms of something that actually started in the brain. The actual source of the problem, the primary source is something in the brain.
Yeah, not always. I mean, their kidney disease is real, but there are levers you can pull in the brain that affect all of these systems.
There's knobs.
Yeah.
On-off switches and knobs in the brain,
Yeah.
from which this all originates.
Yeah.
Would you have a Neuralink chip implanted in your brain?
Yeah. I think use case right now is use a mouse, right? I can already do that. And so there's no value proposition. On safety grounds alone, sure, I would do it tomorrow.
You say the use case of the mouse. Because after researching all this, and part of it is just watching Nolan have so much fun. If you can get that bits per second really high with the mouse, like being able to interact, because if you think about the way on the smartphone, the way you swipe, that was transformational.
Yeah.
How we interact with the thing. It's subtle. You don't realize it, but to be able to touch a phone and to scroll with your finger, that changed everything. People were sure you need a keyboard to type, and there's a lot of HCI aspects to that changed how we interact with computers.